All right, so part E, we're asked to find the mathematics SAT score. So again, now we're being asked to find a value of x. It doesn't say find the probability of that. So find the mathematics SAT score that represents the top 1% of all scores. Okay, so here's where we need to think of the context. So top, our best scores in this case are going to be the higher scores. So best in this case equals, so in the context of this problem, best equals highest scores. And again, you have to keep in mind that the x-axis is an x-axis. As we read left to right, the numbers get bigger, so the highest scores are going to be in the right tail. Okay. So that tells us that the 1% that they give us, that tells us where we are going to put that in the distribution of scores. So as we make a distribution, that 1% that they've given us is the shaded area. Okay, it is not a number down here on the axis. Okay, this is the number that we're after, which if we have 1% above it, that means there's 99% of the scores below it. So really what we've been asked to find here is the 99th percentile. So this problem is asking you to find an x value from a probability. You want to find the x value that has 1% of the mathematics SAT scores to the right of it. And again, I want to emphasize that it's not just because it says top. It's because top scores are going to be in the right tail. Again, if we were looking for our top runners and we were looking at their times for, completing a mile or whatever they're running, our top runners are going to actually be down in the left tail. Okay, so again, context is important here. So remember, the calculator always needs an area to the left. So we need to find the area to the left by taking 1 minus 0.01 and getting 0.99. Okay, so at this particular x value, if 1% of the scores are above it, that means the other 99% of the scores are below it. All right, so on the TI-84, we would use inverse norm. So again, we would go into second vars to get into the distribution menu, and we would use option 3 to get into inverse norm. Again, remember this area on here. This is always area to the left. Okay, that's not always what we've been given. So in this case, we were given 1%, but you'll notice on the calculator we didn't put 1%. We put the 99% because we need the area to the left of x, which was this 0.99. And then the mean was given as 514 and the standard deviation of 117. So again, if you have the newer system, you would enter these three numbers, highlight paste, and push enter. And then it would look like the second screen here. Okay, those of you with the older model, you don't see this intermediate step. You just have inverse norm and it's blinking. You would enter 0.99, 514, 117. And then keep in mind that this output here now is a mathematics SAT score. Okay, it's not a probability. Okay, and again, StatCrunch has the ability to compute these as well, but again, it's just as easy to compute them on the calculator, and that's what you're going to have for your exam and for the departmental final. All right, so no matter what form of technology we use, we see that we get 786.2 if we round that. We'll say those are points. Okay, so if we interpret that here, we can say that, 1% of all people who took the SAT, and again, to be more specific, again, it would be in 2012 because that's what this data is based on. So 1% of all people who took the SAT in 2012 scored over about 786.2 points on the mathematics portion of the SAT exam. Or we could say that, the top 1% of the scores were above 786.2 points. Okay, so our top 1% of the scores were people who had a math SAT score above 786.2. All right, so in summary for this particular section, if you are given an interval of x values and asked for a probability, you use normal CDF. Again, assuming that we know that we have a normal random variable. However, like in this last example, if you're given a percentage or probability and asked for an x value, then you're going to use inverse norm. Okay? So again, both of these functions are useful with normal distribution curves. It just depends on what you've been given and what you've been asked for. So if we've been asked for a probability, that's what normal CDF gives us. If we've been asked for a value of the random variable, that's what inverse norm will give us. And for this course, we never use normal PDF. So like in the binomial chapter, we use binom PDF and binom CDF. Okay, so we never use normal PDF. That does not compute the probability of anything. It's just something that, like, I used it when I used to like trace out the curves on the calculator for some of the captured view screens in the notes and different things, but you will not be using normal PDF. So if we want a probability, you use normal CDF. You want a value of the random variable x, you use inverse norm.